Hey everybody, hope everybody's doing well at home. My name is James Newman. I'm an elementary teacher development specialist manager for the Houston Independent School District. And we're back for another 3rd through 5th grade science lesson. I have my friend Callum here. Callum, say hi.
Hi.
And today we're going to be working on the water cycle. We're going to be using models and diagrams to describe and illustrate the steps of the water cycle. So if we're ready, let's go ahead and get into this. Before we start though, we're going to need some materials, some simple things that you should be able to find around the house. In this lesson, we're going to start with a glass of warm water and a glass of ice cold water. Science safety is always important. If you're doing this by yourself, without a parent help or without an adult helping, the warm water, just warm tap water works. If not, if you want to just leave the warm water out, that's okay. If you have an adult to help you, I just heat up a little water in the microwave and put it in a cup. Ice water, a Ziploc bag or a zipper bag, some kind of permanent marker that can write on the bag, and a notebook or a piece of paper that you could write on. So I set this one up today. Callum and I set this one up. It's a water cycle notebook. Inside we're going to be taking some notes. Your notes don't have to be very specific. Just write down your observations as you go, and at the end we're going to draw a diagram of one of the models that we build today. All right? Okay. So let's start out. So Callum, what is the water cycle? Have you ever heard of this before?
No, I have not.
Okay. All right, so let's think about, we're going to start out with, and at home, if you've heard of the water cycle before, if you already know some of these ideas, this will be a good review for you. If not, we're going to be dealing with some models, and we'll name. The hardest part of the water cycle really is remembering the vocabulary and knowing what happens to water as it goes through this cycle in and around the surface of the earth. So here we go. We're going to start out. I have 2 cups. One of these cups has ice water in it, very cold ice water, and one of these cups has warm water in it. I put a little blue food coloring in the water just so you can see it better. And later in the model that we have, it's going to help with us seeing evaporation and condensation. If you don't have food coloring at home, there are other options. You could put you had some Gatorade or some Kool-Aid or something, you could put that in here, a couple of drops of Kool-Aid in the water just so you could see it. If not, this all still works without the food coloring. All right? Okay, so Callum, in your notebook, and if you could see this, we set up just a couple of cups, drawing a couple of cups, and I want you to think about these 2 cups, this one with ice water, this one with warm water, and kind of observe them, make some notes, draw, label, and then just be thinking about what's happening to water in each one of these cups. And so while Callum's doing that, you at home, you could do that. So get your warm water and your ice water, put them in a cup, and just take a minute to observe. Get a piece of paper out, draw a picture of what's happening, and then we'll come back together in a minute and we'll talk about what is happening to the water, and then we'll go a little deeper into the science behind it. Okay, so I'm gonna wait. I'm gonna give you about a minute. So go ahead. So the question again, or the thinking behind this again, is I want you to think about what's happening to water in each of these cups, in and around the cup, and I want you to explain what you think is happening. All right. Go ahead and get your paper, get your water, start thinking. And don't forget, as you work, don't forget to label your drawings. If you don't know the right words yet, that's okay. We're going to come back to it and we can label them after we practice the definitions just a little bit more. So you're explaining what's happening inside and outside of these cups with the water that's in it. And if you want to, Calvin, you can touch the cup. You can put your hand above the cups. All right, we'll give you about 10 seconds. Remember, vocabulary is not that important right now. We're just describing what we see. Okay. All right, everybody ready? Got it?
Mm-hmm.
Okay, Callum, let's talk about it. So what do you see with these two cups?
I noticed that there were a whole bunch of drops of water on the outside of this cup.
On the outside, huh? Okay. All right, keep going. Sorry.
I also noticed that there was a whole bunch of water forming on the high up part of this cup.
Oh, okay. So is it on the inside or the outside?
Inside.
Okay. So there's water droplets forming on the inside of this cup at the top of the water. And like Callum said, there's water droplets forming on the outside of this cup and dripping down. And we've probably seen that before when you have like a cold soda on a hot day, or just any ice cold drink in a warm place or in any room. Really, it's not that hot in here right now. That these droplets will form on the outside. So what do you think where is this water coming from inside the hot water cup?
I would assume it's coming from this amount of water right here.
Okay, so the inside of the cup.
Mm-hmm.
Do you think it has? What do you think it? Where do you think it's? How's it getting there? Is it just jumping out?
I believe it's rising because
Okay.
you can see the steam around it.
Oh, so this is like the steam coming out. You can't really see it probably in the video, but there's steam coming out of here, and maybe that's just collecting. Okay. All right, and so on the outside of this one, where do you think that water's coming from?
I think it's so cold that when the air touches it, it just goes back to a liquid form on the outside of the cup.
Okay, so you don't think this water on the outside is leaking through and coming outside?
No.
Okay, and just to think about it, another reason for the food coloring in here is this is blue water on the outside. What color is the water on the outside dripping off?
Clear.
It's clear. So maybe it's not coming from the inside. Okay. All right. So that's just a way to start then. What do you think this has to do with the water cycle, Callum?
Maybe it's so. For example, maybe it's when this goes up and this forms clouds because it's so cold up there that I guess the water droplets like come together to form clouds, and this is how they get up there.
Okay, perfect. So maybe this hot water. We talked about energy last time. What type of energy is this that's making the water go up? That's making the water change and go up?
Thermal.
So maybe there's some thermal energy added, right? If we did a video last week where we talked about the forms of energy, and so maybe there's some thermal energy here that's making this water leave the cup, right? And then this, do you think this has to do with thermal energy?
No, because it's quite cold.
So when things get cold, thermal energy, is it added or taken away?
Taken away.
So maybe there's thermal energy interacting with both of these. This is thermal energy being removed, and this is thermal energy being added. Just thinking. We're just kind of thinking ahead. Okay, so our next step then is to really understand this. So we're going to really understand the words, the language behind this, and then we're going to build a model to represent. So this is one model, this is one way to show what could be happening with the water cycle right now, with the water moving around above the surface of the earth, on the surface of the earth, in our lakes and oceans. And I want to create another model that we can watch throughout the day. So this is the part where you'll need your zipper bag, just a little zipper sandwich bag. If you don't have this, you can probably use like a glass like this and cover it with some saran wrap, or like just put a lid on it, or a piece of something to cover the top of it. So what you want really is something clear where you can see what's happening inside, but you want to be able to seal the top. A container, like a sandwich container with a snap-on lid, works just as well. Anything that's clear with a way to seal it. Okay. So what we're going to do with this model, we're taking this bag, this clear bag, and we're going to fill it with a little bit of water. And like I said, I have some water here that has food coloring in it, but this is just so you'll see it better, and it's to help with seeing evaporation and condensation through the cycle. If you don't have food coloring, you can pour a little bit of Gatorade in there just to give it color. You could, whatever you have that has some color in it, it could be green or purple, it doesn't matter. Just to see that the water in the bottom of this model will be a color, and the what happens around it, you'll be able to observe something different. So, Callum, here's your model. And what we're going to do first, we're just going to put some water in there. If you have a place, if you have a sunny window you can tape this into later, that's a good space to have it. So when we put this model together, we're going to put it together and we're going to tape it up somewhere. We'll label it, we'll look at what happens, but the idea is that we're going to be able to see this whole water cycle in this model. Okay, so don't do anything yet. First of all, we're going to take our bag and we're going to put, you don't have to put a whole lot of water in it. I think in the lesson online it talks about putting a cup of water in. I think that's a lot. So I'll hold the bag. Callum, you pour just a little bit of water, just about that much. It doesn't have to be real exact. And if you spill a little bit, it's all right. That's what happens. Science. Okay. So here's a bag with some water in it, right? Go ahead and seal it. Make sure it's all the way sealed up because we want to create an enclosed system, kind of like the Earth, right? Our atmosphere keeps all of that water in. None of the water leaves the Earth's atmosphere. It's all here, and the water that we have and the water that we use and drink was here when the dinosaurs were here, right? So that's a pretty cool thing to think about. Okay, so we have our water in our bag. This is our model. It's sealed. Callum, what do you think will happen inside this bag if we put it in the sun and it heats up?
It will turn out like this warm cup of water did. The water will rise.
So we have our warm cup of water. That's a good connection. I like that. We had our warm cup of water and some steam was coming out of it, and we had some water collecting at the top on the edge that was coming up, right? So as we do our water cycle model, when we put it in the window, we probably see something like this. I don't know. So if we think about it, I want to take this model now and I want to tape it up to the window. So if you have some tape, if you have a space to hang it, you could really set it outside if you set it up right and just set it on the window, right? Okay, so we're going to do that now, and then I want to switch over and I want to have Callum come over to the word wall and to our chart here, so we can explain this a little bit more while our model is doing its thing, while it's showing the water cycle. We want to give it a little bit of time for that thermal energy to make this model work. All right, come on over, Callum. All right, so here we are at the word wall and our anchor chart to do some explaining, right? To really help you understand what this water cycle is all about and the science behind it. So we've started out with a couple of models. You know, our work today is around using these models to describe the processes in the water cycle. So our first example were the two cups, the warm cup, the warm water cup and the cool water cup, and what happened in and around those glasses of water, right? We talked about some of the water leaving the cup, and then some on the cold water, some new water maybe coming around and sticking to the side of the glass. So we did that. We set up our bag. Our bag is working right now, right? We've taped it up to the window. We're waiting for that thermal energy to do its work. And to cause some things to happen. We'll come back to the bag in a minute, but in the meantime, I want to work with Callum. Callum and I are going to work on this anchor chart and this word wall to kind of define some of the words, to label a drawing, to really get an idea of what's happening with this water as it moves all over the world. Like I said earlier, this water that we're drinking now and the water that we use for our showers and to brush our teeth, this water was here when the dinosaurs were here. That's just crazy to me, right? So this water is always moving. It's always the water that we have now might have been on another side of the earth, and it's been here since the beginning. It's a closed system, right? So it never leaves the earth. So let's talk about what really is going on. Okay, so Callum, you ready? Mm-hmm. All right. So let's start out with the vocabulary because this is tough, right? The words are hard. So we need to get the words down and really understand what the words mean. So I'm going to start out with an example. So I have this word. What is this word, Callum?
Evaporation. Evaporation.
Everybody say that? Evaporation. All right, great. So evaporation is, we see a piece of the word in here, vapor, right? Vapor is a gas. This is when water is a liquid, something happens to it and it turns into a gas. Callum, what do you think happens to it? What do you think is added to it to make it turn into a gas?
Thermal energy.
Thermal energy. We talked about that before, right? There's heat added. Where do you think that heat comes from in the water cycle in the world?
The sun.
The sun. The sun is the source of all energy out there, right? So in this water cycle, could the water cycle happen without thermal energy from the sun?
No.
No. Our water would just be sitting there. It would be dirty and nasty. It would never evaporate. There would never be water vapor in the air. We wouldn't have humidity, which in Houston is a good thing, right? But we wouldn't have any moisture, there would be nothing without the energy from the sun, that thermal energy. So I'm going to start with this. So evaporation, think of the word vapor, right? Vapor is a gas. Evaporation is this. So if you can see this, there's liquid water, thermal energy is added, and then that liquid water turns into a gas called water vapor. Thermal energy added, gas, the liquid turns into a gas. All right, so and I'm going to add in a term. The big idea here is that thermal energy is added and liquid changes to a gas. Okay, so Callum, help me out. What is condensation?
I would assume it's when the water vapor is up there, that's how clouds are formed.
Okay. Okay, so the water vapor is floating around, and then what happens? Think about thermal energy.
They clump together and thermal energy leaves.
Ah, I like that. Thermal energy leaves. So thermal energy is removed, it gets colder, and then the water turns into, that gas water turns into what?
Turns into a liquid.
Got it. So we have this. Condensation is, and then now bring this a little closer to you so you can see it. Condensation is, gas is floating around in the air, that water vapor is out there, it's cooler up in the atmosphere, higher up in the atmosphere, thermal energy is removed at that time, and this gas water vapor turns back into tiny little droplets of water that make clouds. We see condensation in other places too. Where do we see condensation in one of our models today?
We saw it on the cold cup.
On the cold cup. So like we said earlier, if you have a soda, cold soda on a hot day, you're gonna notice that water forms on the outside of it. That's not soda leaking out. That's water from the air that's floating around. That gas, that water vapor that's floating, and it touches. What is the can?
It's
How does it feel?
It would be like the cloud saying.
Yeah, it's just like a cloud. That's cold air or cold. That's cold Coke can or this cold can, and the water is touching it. This gas and immediately turns back into a liquid, right? So that's condensation also. So we can think about clouds, or we can think about a cold glass of water on a hot day. Okay, so next we have precipitation. Precipitation, these are all really big words, but they mean things that we're very used to, right? So precipitation, what is that? The clouds are up there, there's these tiny droplets.
It's when the liquid from the cloud gets big enough that it is affected by gravity.
Okay, what state of matter is it, do you think?
Liquid.
Okay, can it be anything else?
It could be a solid if you're thinking of hail.
Okay, hail or snow, we don't get a whole lot of that here. But so when water is in the clouds, when enough of it collects, it'll fall back to Earth, right? What pulls it back to Earth?
Gravity.
Gravity, that's a kind of a side thing, but it's good to know, right? So liquid or solid, rain or snow or sleet or hail is falling back to the Earth. That's called what again?
That's called precipitation.
Precipitation, okay? And as you're at home, say these words as we're going through them, because the more you say them, the more you get used to them. So far we have, what is this word, Callum?
Evaporation.
Evaporation.
Condensation.
Condensation.
Precipitation.
Precipitation. Now we have something that, once the rain hits the ground, right? Once that snow hits the ground and melts, what's going to happen?
This is called runoff. So you could already assume what it's doing. It's draining away.
Got it. So I forgot to add a couple of things here. Let me do this real quick. Condensation is thermal energy.
Condensation is thermal energy leaving the water droplets.
Okay, so and for condensation, thermal energy is removed from the water and it changes back into a liquid. So these are important right here. Condensation is gas changes back to a liquid because thermal energy is removed. And then precipitation is just water falling back to the earth. It can be a liquid or a solid. So we started talking about this word runoff, right? So after the water hits the ground, you said it runs away. It goes away. Gravity pulls it and it goes to the lowest water point of water on the earth. Usually it makes its way to the ocean, or it tries to. So after the rain happens, this is called runoff, right? So this is really, go ahead and stick that up there.
Water drains away after landing on Earth.
So water drains away after landing on Earth, right? Okay, so finally, and I say finally, but none of this really happens first or last. It's an ongoing cycle. So accumulation, some people call it collection. What happens to the water eventually after it runs away?
It collects
Okay.
in rivers, ponds, and lakes, and oceans, and really whatever water formation there is.
That's it, you got it. So some kind of collection of water, it can be a puddle, it can be a lake, a stream, the ocean eventually is where all the water wants to get back to. So that's called accumulation. Say the word.
Accumulation.
Accumulation, or we can call it collection. And again, this is when water collects in like puddles and ponds and things like that. Okay, so here are our vocabulary words. This is the language we need to use now when we talk about the water cycle. So from here, we can't just say water floats around in the air. We call it what?
Water would evaporate, condensation, it gathers, precipitation falls back to the earth, runoff goes to the ocean or lakes, or really drains away to an accumulation. It would collect and form those.
Okay, got it? So we're using, thank you, Colin, that was very good. We're using this language now. Okay, so we have to, this is in science now. We've kind of explored with it, but now we know it, right? So I want to move over to this anchor chart. So if let's switch places here, Colin. Okay, so here you go, I have some markers, I lost them for a second. Okay, so I have a picture of a mountain and the sun right here and the ocean, right? And so this is a model, this is a drawing, this is an illustration, a diagram, whatever you want to call it. This is a diagram of the water cycle, but it's missing some things, right? It's missing the labels. Every time we do any kind of drawing in science, you're going to do this before this is over, we have to label it. We have to make sure it looks scientific. We're going to add our words and our thinking that we put here on the word wall to this chart here. Okay, you ready, Colin?
Mm-hmm.
All right, I want you to talk me through this then. So what happens, what's the source of all of the energy for the water cycle?
It would be thermal energy that comes from the sun.
Okay, so come over here. And let's see. So you remember your... Okay, all right. So thermal energy coming from the sun. I'm going to say sun shining down. Okay, what happens when that thermal energy hits the water?
It heats the water up, and the water turns to gas.
Okay, so I'm gonna do like this. What's that gas called?
That is called water vapor.
Okay, what part of the water cycle is this?
That's called evaporation.
Okay, so I'm gonna... Okay, so I have evaporation. What is this called again?
That's called thermal energy.
Okay, that's called thermal energy being added and evaporation, right? So this turns into water vapor. Is this a liquid or a gas now?
That is a gas.
Okay. So then, once that evaporation happens, eventually it gets up here, right?
Mm-hmm.
What happens to the water vapor as it cools?
It turns into a cloud.
Okay, and a cloud is an example of what?
Condensation.
Condensation. So I'm going to put that up there. I'm going to write condensation. Okay, and condensation is what?
It's
What
when, well, as you can see here, it's when thermal energy is removed and water droplets form together, and we see them as clouds up in the sky.
Okay, is this a...
Today we don't see many.
We don't see many today, you're right. I like that. Yeah, not many today. They're out there though. So what form, what state of matter is this?
That would be still a gas. Well, liquid actually.
Okay, so this is a liquid, it's tiny droplets. I'm going to put some drops in there to help us remember. What is it down here?
That is also liquid.
Okay, so I'm going to write this in here. And this out here is a what?
That up here is a gas. That up there is a gas.
This is a gas, and what do we call it? What can we call it? What kind of a gas is it? It's water...
Vapor.
Vapor. The word is in here, right?
Mm-hmm.
Okay, so we could say water vapor. I don't want to write that right there because it's getting crowded, but water vapor. Okay, scoot over here real quick. Okay, so we have now these clouds are happening, right? Clouds everywhere.
Mm-hmm.
What's going to happen when this fills up? When these clouds fill up with too much Too much water, too much liquid water.
The liquid gets more dense than gas, so it would fall back down to Earth, which is called precipitation.
And what pulls it down again?
Gravity.
Gravity, got it. Okay, so now we have our precipitation falling. And as this precipitation falls, can it be, what state of matter is it?
It would be liquid or a solid.
Liquid or a solid. Okay, and what is it called again?
That is called precipitation.
I'm going to write that right here. These are big words. Precipitation. Okay, got it. So our evaporation from the thermal energy is added. Water vapor, this is a gas, condenses into a liquid because thermal energy is removed. Precipitation
Falls back down
to Earth. Then what?
Then it would run off. So it would go down the mountain here and go back into the ocean.
Okay, so
And there it would accumulate, also collect.
I'm going to put runoff right here. And then it will collect down back in the bottom again. And what do you call that again?
Accumulation.
Accumulation.
And then the cycle starts over.
And then that cycle keeps on going. Okay, come stand over here, please. So, scoot out of the way just a little bit so everybody can see. Okay, so at home, we've kind of put these ideas together, right? Now it's going to be your turn in a little bit. So let's go through these words one more time. We have evaporation, condensation, precipitation, runoff, and accumulation. And then this is kind of, we turned it into a graphic representation of what's happening out there. It might not look exactly like this. There might not be an ocean and there might not be a mountain, but the water cycle is always happening. There's always water vapor being created because thermal energy is being added. That water vapor eventually will cool off and turn back into a liquid. There will be some precipitation somewhere, and there will be some runoff, and there will be accumulation. And this cycle goes on and on and on. It has been since the beginning of the earth and will keep going until whenever, right? But this is the water cycle. All right. So now we're going to go back to our model, and we're going to do some labeling. We're going to do some talking through what that looks like, and then we'll close this lesson out. So Callum, let's get back to our seat. All right. So while Callum's finishing up his work here, his thinking, his model, and at home you're working on yours, you're drawing your diagram of the water cycle and labeling it. I just want to, you're going to wrap that up. Make sure to share it with someone today. Check back with your model today. Make sure you labeled it right. You know, just be thinking about this. And if you go outside, if you take a chance to go out and you see a puddle, you know, call it what it is. That's accumulation. If you see a cloud in the sky, that's an example of condensation. So make sure you're using this language through the rest of the day. So I want to say thank you so much for spending time with us to do this lesson on the water cycle. And for kind of working through some pretty complex language and a tough idea in science. It was great having you. Parents, if you are interested in watching this video again or accessing this video again, or for other lessons, you could go to the HoustonISD.org/home website, HoustonISD.org/home. If you go to the left menu bar, you can click on Elementary Students, and you'll see some lessons that we've been working on that are at-home lessons that are hopefully minimal material, so you can do those at home. They're easily adjustable. They're just like this one. I kind of added a little bit to it, but this is a way for you to kind of keep the science going at home. So again, you go to HoustonISD.org/home. Go to the left menu bar and click on Elementary Students. There are also some for secondary students if you're interested. And these are day-by-day lessons that you can access. They're printable, or you can view them online, or they're interactive. There are links in the lessons that access interactive lessons. There are presentations that you can click on. So we've there should be something for everybody out there. Also, if you'd like to watch this video again, like I said, you could go to that same website, HoustonISD.org/home, and scroll down until you see HISD at Home TV. There's a link for that. And this video and many more are there. We're working on creating one video a week for kindergarten through second grade science, and another video every week for third through fifth grade science. So keep coming back and checking, and we hope to see you soon. Thank you again for spending some science time with us today.